All right, so we're talking Pythagorean identities. This should remind you of the Pythagorean theorem. And what's the Pythagorean theorem? A squared plus b squared equals c squared. And so these are all going to be something squared plus something squared is equal to something squared, all right? And so we're just going to be manipulating them. Instead of side and the hypotenuse, we're talking about sides and things in terms of sines and cosines. Remember when we did the unit circle, we made all those triangles? So every point on the unit circle has to do with the triangle, right? Mm-hmm. And so that's why we have some identities that deal with trig that are based off the Pythagorean theorem, because all of those points on the unit circle came from triangles. And so I'm not going to tell you what they are. I'm going to let you figure them out, all right? But I'm going to show you. We'll do the first row together so you can kind of see what I'm talking about, and then I'm going to give you some time so you can work through the rest of it, okay? All right. What is the sine of pi over 6? 1/2. Everybody good? 1/2, right? What is the cosine of pi over 6?
Cosine will be the square root of 3 by 2.
Over 2. Square root of 3 over 2. And so then the next thing we're going to do is we're going to square these, because we're talking Pythagorean theorem, right? And everything in the Pythagorean theorem is squared. So what is 1/2 squared? Or what is 1/2 times a half? Or you can think of it as square the top, square the bottom. 1/4. So a bunch of ways you can do that. 1/2 squared is 1 squared and 2 squared. Or it's 1/2 times a half, which would be 1 times 1 and 2 times 2, right? A fourth. And then what is the square root of 3 squared? What's the square root of 3 squared? That's just 3. And then over 2 squared, which is 4. So the cosine squared of pi over 6 is 3 over 4. And then the last thing I want you to do, because in the Pythagorean theorem it says, hey, take a squared plus b squared, add them together, right? What is the sine squared plus the cosine squared of this value?
1.
Equal to 1. 1/4 plus a third is a whole. Yeah. All right. I want you to finish this section right here. So do the next 2 rows. This row is based off of pi over 4. The next row is based off of pi over 3. And pay attention to your last column and see if you can come up with any observations there. Okay. So finish this section and see what observations you have.
I think we're going the observation bit. Yep.
I'll do the first row with you, and then I'll let you try the other ones by yourself, just like we did this one. You don't know what is?
1/9 plus 3/4.
Are you doing this section?
No, I'm doing the third one.
This one?
Yeah.
Which what? What did you get for sine of pi over 3 then?
1/3.
What?
Yeah, I think you just pulled the wrong number. Sine of pi over 3.
Oh, okay. It's 1/2.
Yeah.
Yeah.
Well, not 1/2, isn't it? Square root of 3 over 2, right? Yeah. And then cosine of 1/3 is 1/2.
Yeah.
All right.
Thank you.
Mm-hmm. All right, so in this middle row, the pi over 4, the sine of pi over 4 was square root of 2 over 2, right?
Correct.
Cosine, square root of 2 over 2. Correct. What happens when you square the square root of 2 over 2? 2 over 4. Or you could think of it as 1/2, right? Yeah, that'd be fine too. I'm cool with 2 over 4. Cosine square root of pi over 4, so we're squaring the exact same thing. 2 over 4, and if you add them together, what do you get? 1. And then this bottom row is exactly the same as the top row, except for the sine and the cosine are reversed, right? When you square them, though, you just get the reverse, 3/4 and then 1/4. And since we're adding, that didn't really change anything. It's still equal to 1. So the first Pythagorean identity, and the most famous one out of all of them, is that sine squared plus cosine squared equals 1. Does not matter what angle we were looking at. We did the 3 in the first quadrant. You could have picked any of them that you would have gotten sine squared of theta plus cosine squared of theta, and theta is just some angle, literally any angle you want it to be, will always equal 1.
Yeah, but always have to be the same angle.
Those two have to be the same angle. Yes, you can't do like a pi over 3 and a pi over 4. That won't work. Whatever the angle is, as long as they're the same, then if you square them, add them together, you'll get 1. All right, and I'm going to kind of throw this out there. Remember Pythagorean identity based off the Pythagorean theorem, based off a right triangle, correct?
Yeah.
And this is, when we're talking sine, cosine, we're talking about the unit circle, right? What is the hypotenuse on a unit circle?
And always 1.
Always equal to 1, right? The radius of the unit circle is 1. This is your x coordinate, right? And this is your y coordinate. When we talk x and y on the unit circle, x is representing the cosine, and y is representing the sine of the angle. So if the Pythagorean theorem is x squared plus y squared would be 1 squared, then cosine squared plus sine squared would be 1 squared, which is 1. Yeah, so that is exactly where this Pythagorean identity comes from. All right, there are 2 more. They're a little bit more complicated, but let's go ahead. We'll do the first row together, and then I'll give you some time to work. So tangent of pi over 6. So pulling out your little hand trick, right? Pi over 6 is the first one. Tangent is sine over cosine. So the 1/2 is on the top. The square root of 3 over 2 is on the bottom. So this will be square root of 3 over 3. And then the secant of pi over 6, so we're still at pi over 6. Secant is the reciprocal of cosine, right? Cosine is the square root of 3 over 2, so its reciprocal is 2 square root of 3 over 3. And now we're going to square these. When you do Pythagorean identities, they're always squared because Pythagorean theorem always squared. So square root of 3 over 3 squared will be 3 over 9. You can simplify if you want, but you don't need to for this activity. And then here, this is a little bit more complicated, right? 2 square root of 3, if you square that, square both of them and then multiply, because technically they're being multiplied together. So 2 squared is 4. The square root of 3 squared is just 3. And 4 times 3 is 12. And then the denominator, if you square that, you'll have 12 over 9. And then we switched it up just a little bit. Instead of adding these two, we want you to take the tangent and subtract the secant. So 3/9 minus 12 over 9 is going to be negative 9 over 9, which is equal to negative 1. So try the next one and see if you get the same result.
So the square root of 2, the square root of 2 divided by 2 over the square root of 2 divided by 2 is 1, right?
Yes. All right, so we said tangent of pi over 4 was 1, right?
Mhm.
The secant of pi over 4 is the reciprocal of the square root of 2 over 2, so that's just square root of 2.
Okay.
Tangent squared, so 1 squared is just
1,
1. The square root of 2 squared is
2,
2, and 1 minus 2 is
and 1.
negative 1.
Mhm.
All right, so far we see a pattern. Let's check pi over 3. We'll just make sure. What is the tangent of pi over 3? So pi over 3 is this one. Tangent is sine over cosine. So the square root of 3 is on the top. So that just makes the tangent the square root of 3. The secant of pi over 3, secant is the reciprocal of cosine. Cosine is the first one, so 1/2. Reciprocal of 1/2 is just 2. And then tangent squared would be the square root of 3 squared, which is just 3. Secant squared would be 2 squared, which is 4. And 3 minus 4 is, in fact, negative 1. Those ones that you didn't have to go through all of the crazy fractions, right, to get there? So there is a relationship as well for a Pythagorean identity in terms of tangent and secant, and the relationship is that tangent squared of an angle minus, in this case, secant squared of an angle will always be equal to negative 1. Now, we don't typically leave it like this because of the negatives. We don't really like the negative. Like the other one's really nice because it's like positive, positive, right? Positive. So when you see this identity, most likely it's going to be written in a different fashion, all right? And so what they're going to do is they're going to move some terms around. So they're just going to take this secant squared and move it to the other side. When you move it to the other side, it becomes a positive. They're going to take the negative 1, move it over here. When it moves over there, it becomes a positive. So if you ever look it up or anything like that, you'll see that it says tangent squared theta plus 1 equals secant squared theta. They like to write that one because everything's all positive. It looks nice and pretty, right? Right. The nice thing is, though, is technically you can rearrange this however you want, right? It's just moving terms. What was that? It's not equal to positive 1. If you were to, the only way to get it equal to positive 1 is if you were to move this over and say secant squared minus tangent. Then you'd get a positive 1. Yeah, but they like to write it here where it's tangent squared plus 1 equals secant squared. Everything positive. Okay? And we're going to use these quite a bit throughout the rest of the trimester, so you'll kind of get the hang of being able to move them around and such.
Okay.
All right, here's the last one. There is a relationship between cotangent and cosecant. So let's go ahead and fill in the first row. Cotangent of pi over 6. So pi over 6 is the first one. Cotangent is cosine over sine. So cosine is the square root of 3 over 2. Sine 1/2. So since square root of 3 is on the top, this will just be square root of 3. Cosecant is the reciprocal of sine. So the reciprocal of 1/2, which will be 2. And then we're going to square both of these. So the square root of 3 squared is just 3. 2 squared is 4. And if you subtract those, once again, this is a subtraction one, we'll get negative 1. Do you think you know what's going to happen for the other two?
Will be equal to negative 1.
They're all going to be equal to negative 1, right? Is everybody okay with that, or do you want to actually work through them and see?
I think
you believe me? You believe the pattern you've seen so far?
If the first 3 timing, we keep all 3 shells and good.
By the way, it's actually really similar because tangent, this one here, right? And cotangent are reciprocals.
Okay.
So this line right here of the pi over 6 was actually the same line as pi over 3 because of the reciprocals. Pi over 4 is going to be the same as pi over 4. This is 1. The cosecant, which is reciprocal of cosine, is the same, reciprocal of sine is the same as the reciprocal of cosine because, right, those are the same x's and y's. So it's also 2. Or not 2, square root of 2. square root of 2, right? And then so then cotangent squared is 1. Square that cosecant, you'll get 2, and 1 minus 2 is -1. And then this bottom row will mimic tangent of pi over 6, that row there. So this is square root of 3 over 3, 2 square root of 3 over 3, and then you can calculate those and get your -1. Miss Bird? Yeah, I do. Okay. Yeah, you're welcome. Daniel, Miss Cobb said she's been in and out of the building today, so she's going to email you tomorrow. Okay. All right, so what? This was 3 over 9 and 12 over 9. And when you subtract, you still get -9 over 9, which is 1. So the relationship here is that the cotangent squared of theta minus the cosecant squared of theta is equal to -1. Now, just like the last one, this is not the standard way to write this. They're going to move some terms around so that everything is positive. So what they're going to do is they're going to go ahead and do some flip-flop here. So they're going to say, all right, we'll leave the cotangent squared positive. We're going to move the cosecant over because it'll make it positive, just add it over, and add the 1 over so that it will be positive as well. So +1 will be equal to cosecant squared. So those are your 3 Pythagorean identities. Take a moment and write them on your orange sheet under Pythagorean identities. Put the sine squared plus cosine squared equals 1 on the top, and then I don't really care the other 2. But that's the one you're going to use the most, so put it on the top for sure. You should have 3, yeah, right? All 3.
No, I'm saying like.
Oh, no. Just put this one and this one. Yeah. All right, I'm going to show you one more way because this is going to be the easiest one to remember, right? Sine squared plus cosine squared is 1. The other 2 are a little bit trickier to remember. Just know that none of the trig functions are repeated, right? Each one has 2 unique trig functions. It never repeats. And the 2 C's go together, right? But it's hard to remember +1, where does the 1 go, which one adds, right? Those ones, it's just kind of complicated. So here's another way to remember where these come from. So if you have this one memorized, what you can do is you can divide each one of these terms by sine squared, because as long as you divide everything by it, we're not changing the value of our equation here. We're keeping it equal. And look at what happens. What is sine squared divided by a sine squared? That's just going to be 1. A cosine squared divided by a sine squared. Well, we know cosine divided by sine is equal to opposite of tangent, which is cotangent. And since they're squared, it's actually equal to a cotangent squared, right? Squared divided by squared, cotangent squared. So that's plus a cotangent squared. And then over here, you have 1 divided by sine squared. And 1 divided by sine we know is, what's the reciprocal of sine?
Oh, yeah. Maybe.
Cosecant, right? Cosecant. And since it's sine squared, it's going to be cosecant squared of theta. And if you look, this is actually this one, right? Just the 1 and the cotangent have been reversed. They've been flip-flopped. So if you have this one memorized and you're like, shoot, I need one of the other ones and I can't remember what it is, you can always divide each of those by sine. It'll give you one of them. Now, if you want the other one, guess what we divide them all by? Instead of sine, we divide them all by
Cosine.
Cosine. That'll give us the other one. So sine squared over cosine squared. Well, we know sine over cosine is equal to
Tangent.
tangent. And so since they're both squared, that'll be a tangent squared. Cosine over cosine is equal to
1.
1. So since they're both squared, it's still just equal to 1. And 1 over cosine squared, that would be the reciprocal of cosine, which is?
Will be co-negative. I think I call it. Oh, sec.
Secant, right? Secant. And so that equals secant, and because that was over a cosine squared, it's a secant squared. And so there is the other one. So that's the second one that we had found. So if all else fails and you just remember the main one and you need one of the other ones, just divide by sine squared, divide by cosine squared, and you can get them, all right? All right, so what we're going to do is we're actually going to use these identities to help us do some solving, all right? So this is going to be kind of different. So first off, there was an error on your paper, so it should be, I think on your paper it says square root of 5 over 6.
Yeah.
So flip it around, so it's actually 6 over the square root of 5 for me. I caught that after I had printed everything, sorry. All right, so if the cosecant of theta is 6 over the square root of 5, determine the two possible values for cotangent of theta. So there's going to be two options here, and we're going to use a Pythagorean identity to help us do the solving, all right? So if you go back to your Pythagorean identities, only one of them has cosecant and cotangent, and that's this one, right? So we're going to use this identity as essentially a formula to figure out this cotangent. So it was 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. And we know the cosecant, and we're trying to find the cotangent, so we're going to plug in those values. So over here, this would be 6 over the square root of 5, and that is being squared because it's a Pythagorean identity. Here you have 1 plus cotangent squared theta. And so now we're just going to do some solving here to figure out what cotangent is equal to. So I'm going to start by squaring this side. So 6 squared is 36. The square root of 5 squared is 5. 1 minus cotangent squared theta. Oh, sorry. Why did I change those to a minus? I don't know. Plus. My bad. Plus, yes. Almost messed myself up. All right, over here, we have to get cotangent by itself, cotangent of theta. So we have to get rid of the 1 and the square. So which one should we get rid of now? The 1. How are we going to move the 1 over? Subtract 1. Now, when you subtract 1 from a fraction, you really want to change the 1 to the right fraction, right? Over 5 so that they match. Just like we were doing with our pies and stuff, it's the same idea. And so we'll have cotangent squared of theta equal to 36 minus 5 is 31, and then that's over 5. And last but not least, to get cotangent completely alone,
you got to do the square root.
Got to take the square root. It's being squared right now, so we'll square root it. And so cotangent of theta is going to be equal to the square root, and you can simplify this as the square root of 31 over the square root of 5, right? You can square root top, square root bottom. Neither of those are nice square roots, though, are they? No, that's a bummer. And you do need to include a plus or minus. Anytime you take a square root when you solve, the answer could be positive or it could have been negative. And that's where the two possible values come in. They come in from the plus or minus. We didn't have to solve two different equations or anything. It was just plus or minus there at the end. Now, technically, one last thing, you should rationalize this, right?
Yeah, we should.
We should. So you would times by the square root of 5, right? And times by the square root of 5. So we would say plus or minus. The denominator, the square root of 5 times the square root of 5 is just
Okay, 5.
5. And then on the top, go ahead and multiply those together. So that would be 1 square root 31 times 5 is 155. 30 times 5 is 150. One more would be 155. And then technically, if 155 simplifies, you should also simplify it, right? The good news is it doesn't simplify. There's no perfect square in 155, so we're good. So there's our 2 possible values. All right. We're going to keep going. So theta is an acute angle. What does it mean to be acute?
Acute angle is less than 90 degrees.
Less than 90. So if we're talking that an angle is less than 90, and think about what you know about the unit circle, what quadrant is that in, less than 90?
Less than 90, what quadrant?
Would be in Q1.
Q1.
So if I ask you to find the value of tangent in Q1, is that positive or negative?
That'll be positive.
That's going to be positive. So when we do this problem and we go to take the square root, the plus or minus, we don't need to worry about it because we're saying, hey, less than 90, so it's in Q1, so tangent is going to be positive. So I don't want the plus or minus, I just want the plus, right? All right, I have cosine and I have tangent. So let's go back to our identities, cosine and tangent. Which one of the 3 should we use? I'm going to get rid of this so it's not confusing.
Sine, cosine.
You could use sine and cosine, right? If you use sine and cosine, you'll figure out the sine, and then you'll use the fact that tangent is sine over cosine. That's not the only one you could use. You could actually use another one.
You could use secant.
You can use this one because secant is the reciprocal of cosine, right? That would be an option too. So you kind of have 2 options. I'm going to use the sine plus cosine squared. Sine squared plus cosine squared. So we'll use this one. Sine squared of theta plus cosine squared of theta is equal to 1. All right, and we know cosine is 0.6, so we can say sine squared theta plus 0.6 squared is equal to 1. And then we're going to solve for sine. So for starters, what is 0.6 squared or 0.6 times 0.6?
0.6.
It's actually not that hard once you know what we're looking for.
0.36.
0.36, yeah. 6 times 6 is 36.
I was thinking
So
that, but I was like,
0.6
I was wrong.
was 0.36, yeah. So sine squared theta plus 0.36 equals 1. So what can we do now? Subtract the 0.36, so we'll have sine squared theta equals, what's 1 minus 0.36? Move that over. $1, take away 36 cents. How much change you giving the person, right? 64. So 0.64. And then last but not least, to get sine completely alone,
There we go.
take the square root. Do we need to worry about plus or minus?
No, because you don't be on the square.
We're in Q1, right? In Q1, and sine in Q1 is positive. If sine in Q1 were negative or we were in a different quadrant, we'd put the negative in instead. So what is the square root of 0.64?
0.8.
0.8, yeah. For the same reason, 0.6 squared, right, was 30.36. Reverse that, 0.8. So then last but not least, it says find the value of tangent, right? And we know tangent of theta is the sine of theta over the cosine of theta. That's actually what we call a quotient identity. Quotient meaning it was divided. Sine is 0.8. Cosine is 0.6. And we actually can do some simplification here. Yeah. How does 0.8 and 0.6 simplify?
4 over 8.
0.4 over 0.3, right? And then technically, it would just be 4 over 3, yeah. You could times them both by 10, right, and get them out of the decimals, and so that would be 4 over 3. So your tangent is 4/3. So that means that this actually came from a 3, 4, 5 triangle, which is really annoying, isn't it? We did all that work and it was just 3, 4, 5. If tangent is 4 over 3, opposite over opposite over adjacent, right? The hypotenuse has to be 5 because it's just a 3, 4, 5. Not on the unit circle though, is it? It's not one of the nice points on the unit circle, but it came from a 3, 4, 5 triangle.
No, that's really annoying.
It is,
I
isn't it?
mean, why do you do all the work just to figure out that, it's 4, 3, 5?
You could have at the beginning when it said cosine was 0.6. 0.6 is 3 over 5 as a fraction.
Yeah.
And if you would have recognized, you could have avoided this, but nobody's recognized so far. So, all right, sine 15 over 17, tangent of theta is less than 0. What is the value of cosine? So let's start with this information that they give us here. The tangent of theta is less than 0. So what does that imply? Not necessarily decimal, because like -2. Think about in your unit circle, where is tangent less than 0? That implies it's negative, right?
There's 2 places that could be positive. It could be in the second quarter or the fourth.
It's either in Q2 or Q4, right? In Q1, tangent's positive, and in Q3, tangent's positive. So Q2 or Q4. Now, there's actually enough information to tell us which one specifically. The sine is a positive. So, is it Q2 or Q4? Which one is sine positive? Q2. So, we know based off of that information that this is in quadrant 2. So, if I'm finding cosine in quadrant 2, cosine is negative. So, this immediately will be a negative number, right? Some kind of negative. So, when we go to take that square root and we have the plus or minus, we don't need the plus, we need the minus. All right, I have sine, looking for cosine, so we're going to use that exact same identity. Sine squared theta plus cosine squared theta equal to 1. Sine is 15 over 17. So we'll put that in there. And we have to square it. So 15 squared over 17 squared. So what is 15 squared?
If I remember correctly, it was 255, no, 225.
225, you're right, 225, yep. And then 17 squared took us a little bit this morning to figure out. If you forget and you can't use a calculator, you can always just write off to the side 17 times 17. 7 times 7 is 49, so carry the 4. 7 times 1, 7 plus 4 is 11, right? Put your 0 placeholder. 1 times 7 is 7. 1 times 1 is 1. And you add those numbers together. So it'd be 9, 8, and 2. So 289. Miss Bird? Yeah. They would have to take that up with TC or talk to Miss Graziano. I don't think so. But I don't know for sure. Yeah, I'm not 100%, so I would say talk to Miss Graziano. Yeah. Okay. All right, so we have that crazy fraction, right? Plus cosine squared theta equals 1. So what do we need to do now? Yeah, take that fraction, right? Subtract it over on both sides. So that'll get rid of it over here. Now, when you do the subtraction, you should change the 1, right?
Yes.
Change the 1 to 289 over 289. So we have the cosine squared of theta equals something over 289. So let's do the subtraction. 289 minus 225. Well, the 200s, right? They'll simplify each other out. So you can think of this as just 89 minus 25. 89 minus 25. What was that? 64. Don't worry about simplifying. Take the square root. Yeah. Take the square root. So we'll have cosine of theta. Square root of 64? 8 square root of 289. Where'd the 289 come from?
Yeah, 15, 17.
17 squared. So if you take the square root of it, you get 17. And did we need the positive or the negative? We needed the negative, right? Because we said cosine had to be negative because it said tangent had to be less than 0, which is negative. So the cosine of theta is negative 8 over 17. All right, one more we're going to talk about. So it says use the Pythagorean identity to simplify sine squared of theta over 1 minus sine squared of theta. And so at the very beginning of this trimester, I said, hey, there's going to be one thing that we're going to work on that you're probably not going to be a huge fan of. And this is one of it. It's simplifying expressions and kind of like verifying expressions. We're trying to use what we know about sines and cosines and tangents and all that fun stuff to simplify these, all right? And so this is kind of your first intro to take a look. We will do a ton more after spring break, so in the next unit. So I have a couple of these in your homework for you to practice, but it's not on your test this time, okay? So if you're like looking at this and then you try the homework and you're like, I have absolutely no idea, don't freak out. It's kind of like a little intro saying, hey, this is some of the stuff we're going to see in the future, kind of like warming you up to the idea, right? Because they're all sine squared, I'm thinking we need to use the Pythagorean identity of sine squared plus cosine squared equals 1, right? Now, it wants us to simplify. The numerator is pretty simplified, right? The denominator is what's a little bit more complicated there. So we're going to simplify the denominator. 1 minus sine squared is actually a version of this. If you move the sine squared over, you'd have 1 minus, right? So we can say the cosine squared is equal to 1 minus sine squared. Are y'all okay with making that statement? We're editing that Pythagorean identity just a little bit.
Yeah.
Now what we're going to do is we're going to do a substitution. We're going to replace the 1 minus sine squared in the denominator with what 1 minus sine squared equals, and it equals cosine squared. So this becomes sine squared of theta over cosine squared of theta. So already we're simpler, right? But this actually goes one more step because we know the relationship between sine over cosine, which is tangent. And so since they're squares, you can call them tangent squared theta. So if you are looking at some angle, whatever angle you want to look at, and if you want to calculate this value here, instead you could actually just calculate the tangent and square it. So this would actually be a lot easier to calculate than this guy would, right? All right, so it's kind of your first intro into those verifying. But like I said, they're not on the test. I have a couple practice for the homework for you to just kind of take a look and get a chance to see because we will see them after in our next unit when we come back from spring break, all right? They get harder. Trust me. They get harder, yes.
I was gonna say, like, if they're like that, then that's okay.
Well, and that's why I'm trying to like introduce you like slowly but surely. This is a really good spot to like, hey, by the way, this is coming. In the future though, especially next unit, they will be harder for sure.
Oh, thanks.
Yeah, you're welcome. And so the next page it's the next 2 pages are your homework. And you're finding cotangent and tangent, and I give you the sign, and then I give you some information. And so you should use the fact that secant of theta is less than 0 to figure out what quadrant this is in, right? And then from there, find one of the 2 and use that to find the other, okay? So there's actually multiple ways that you can do these problems, all right? So it's not like you have to do it this specific way. Use the identities to help you manipulate and see what you can come up with, okay?
Okay.
Yes. And then the next page is a couple more practice there. And then here's the other ones that I was talking about. So maybe a little bit harder. I don't know, kind of check it out, see what's going on. And then I do have this little bit more of a challenge type question to see if you can, this would be like an application of a Pythagorean identity.
Okay.
So,
Cool.
yeah.
Do we have to do number 15?
You do not, but if everything goes really well, give it a shot.
Oh,
Okay.
That's
Because that's looking kind of hard from just like not doing